In this video, I'll try my best to give you a quick explanation about 9 different dimensionless numbers that you might have come across as an engineering student. These are the 4 things that I'll be dealing with: what it compares, what does it mean, formula, and a simple example. Let's begin with Reynolds number. Think of every dimensionless number as a tug of war between two different physical effects. Okay, so Reynolds number is inertia versus viscosity, where inertia is nothing but the tendency of a fluid to keep moving, and viscosity is the resistance to flow, or it is the layer movement. And coming on to the formula of Reynolds number, you might have heard of rho v L by mu, right? Over here, rho is the density, v is the velocity, and L is the characteristic length, and mu is the dynamic viscosity. Coming on to a simple example, honey versus water. Honey has high viscosity and it resists flow, whereas water, on the other hand, is relatively having a lower viscosity and it flows easily. As the velocity increases, inertia becomes more dominant. So, if inertia becomes more dominant, the flow is going to turn into a turbulent flow, which is nothing but a chaotic flow. And if viscosity dominates, then it is going to be a laminar flow, which is a smooth and calm flow. Prandtl number: momentum diffusivity versus thermal diffusivity. Momentum diffusivity tells us how quickly momentum spreads, and thermal diffusivity, on the other hand, tells us how quickly heat spreads. So, it is basically a tug of war between momentum diffusivity and thermal diffusivity. And coming on to the formula, it is nu by alpha, where nu is the kinematic viscosity and alpha is the thermal diffusivity. A simple example would be: imagine a spoon moving through hot tea. Momentum from the moving spoon spreads through the tea while heat is also spreading, and Prandtl number compares these two spreading effects. Coming on to Nusselt number, it is a tug of war between convection and conduction. We all know that convection involves heat transfer between a surface and a moving fluid, and conduction is the heat transfer through a material due to a temperature difference. Coming on to the formula, it is HL divided by K, where H is the convective heat transfer coefficient and L, as you know, is characteristic length, K is the thermal conductivity. A simple example would be: think about a hot plate. With still air, heat transfer is less effective, but when you turn on a fan, the moving air carries heat away much faster. So Nusselt number is nothing but convection versus conduction. Coming on to grashof number, buoyancy versus viscosity. Buoyancy causes a fluid to rise or fall because of density differences, while viscosity resists the movement of the fluid. A simple example would be: think about a hot cup of tea. The air above it gets warm, becomes less dense, and rises, while cooler air comes down. Buoyancy drives this movement, while viscosity resists this movement. This is nothing but like natural convection. Then we have the biot number, which is internal conduction versus surface convection. Internal conduction is heat moving through the inside of a solid, while surface convection is heat transfer between the solid surface and the surrounding fluid. This is the formula of biot number. It is better to concentrate on the concept and an example before moving on to learning all the formulae. So first of all, let's concentrate on the concept and examples. So coming on to a simple example, imagine a hot potato. So heat from the inside has to travel through the potato by conduction, while heat is leaving its surface through convection. So biot number compares these two effects, and that is nothing but internal conduction versus surface convection. Now coming on to Mach number, it is a tug of war between velocity and the speed of sound. So Mach number compares velocity with the speed of sound. Velocity is just simply speed of an object, and speed of sound is how quickly pressure disturbances travel through any medium. Formula is v divided by a, where velocity divided by speed of sound basically. And an example would be: imagine an aircraft flying at the speed of sound at that particular location. So that would be approximately Mach 1. Coming on to froude number, it is inertia versus gravity. We have discussed what inertia means a lot of times in this video itself, and we all know what gravity is, I assume. Coming on to the formula, it is v divided by square root of gl. V is the velocity, g gravitational acceleration, l is characteristic length. A simple example would be, think about a boat moving through water. The boat's motion creates inertial effects while gravity affects the water surface and the waves. Froude number compares these two effects. Coming on to Weber number, Weber number compares inertia and surface tension. Inertia we have discussed a lot of times in this video, and then surface tension is nothing but tendency of a liquid surface to hold itself together. Coming on to the formula, it is rho v squared L divided by sigma. Rho is the density, v is the velocity, L is the characteristic length. We have discussed that L is characteristic length a lot of times in this video. I hope you remember. And sigma is the surface tension. Coming on to a simple example, think about a water droplet. Surface tension tries to keep the droplet together while strong inertial effects can deform it and eventually break it into smaller droplets. Coming on to the Euler number, it is a tug of war between pressure and inertia. We all know what pressure is and we all know what inertia is. At least in this video, we have spoken about it like 2 or 3 times. And coming on to formula, it is delta P divided by rho V square, where delta P is the pressure difference, rho is the density, and V is the velocity. A simple example would be, imagine water flowing through a pipe. A pressure difference pushes the water forward while the moving water has inertial effects. Euler number compares the pressure effect with the inertial effect. So basically, think of a dimensionless number as a tug of war between two different physical effects. Thank you for watching.